Statics, 2008, question 7b. So here we have two equal uniform rods, AB and BC, and they're smoothly jointed at B, and they're in equilibrium, with the end C resting on a rough horizontal surface. The end A, we're told, is held above the surface, and the rod AB is horizontal, and the rod BC is inclined at an angle of 45 degrees to the horizontal. If C is on the point of slipping, find the coefficient of friction. So the first thing we're going to do is mark in all our forces on our diagram. So A is held above the surface, and we're not told at what angle it's held above the surface. So we'll just call that theta, because AB is horizontal, so it's going to be at an angle of theta with respect to the ground. And we'll call that force S. We have two equal rods, so I'm going to say the length of the rods to be 2L. So therefore the weight will act through the centre of gravity for rod AB, and the weight will act through the centre of the gravity for rod BC. We're going to have a contact force with the ground. And then if C is on the point of slipping, we'd expect it to slip to the right, and therefore the friction we would expect to be to the left. So our limiting friction comes into play. So that would be mu or, and it's a rough ground, hence friction. So because we have two rods here together, we're going to take our clockwise moments and our anticlockwise moments, and I'm going to take it for the system first, and I'm going to take my fulcrum to be at A. So I'm going to mark my fulcrum on my diagram. By taking my fulcrum at A, that's going to eliminate the force S, because the perpendicular distance will be 0. Okay, so now I need to work out, well, what's going to be my clockwise and what's going to be my anticlockwise moments. So I can see the weight is going to pull the system clockwise for both AB and BC, and also mu or will pull the system clockwise. And then I can see or will pull the system anti-clockwise. So say my clockwise moments. Well, I'm going to have my fulcrum at A, and then my weight acting down. So that means that the perpendicular distance is going to be L. If I look at the rod BC, then I'm going to have to work out what my distance is going to be. So before I can do that, I'm going to actually look at the triangle, which is 45 degrees, and that's B and that's C, and that's going to be 2L, because I'm taking the length of my rods to be 2L. So that makes this the opposite, the adjacent, and the hypotenuse. So therefore the opposite is going to be 2L sine 45, which is 2L over root 2. And then the adjacent is going to be 2L cos 45, which is, of course, 2L over root 2. So that means if I look at the weight, well, the weight's distance is going to be L, and that's 45, plus the 2L. So therefore, it's going to have a distance of not 2L over root 2, but L over root 2. So this distance here will be L over root 2 plus the 2L. Now, if I look at or, or mu or I should say, for my clockwise moment. And again, I have A, B, and C. So mu or is acting along C. So the line of action for mu or is this. And therefore my perpendicular distance to A is going to be the height of that triangle, which is 2L over root 2. So now I have my perpendicular distance for the weight of the rod AB, the weight of the rod BC, and the limiting friction there, mu times or at C. So if I look at my anticlockwise moments and I work out my perpendicular distance, I can then set up my equation. So my perpendicular distance for or, well again, there's A, there's BC. So we have A, B, and C. And or is acting up. So therefore my perpendicular distance for or to the line of action for A is going to be all the way across. So that's going to be our 2L and our 2L over root 2. Okay, so now I have my perpendicular distance for each. I can set up my equation. So I'm going to have my clockwise moments is equal to my anticlockwise moments. So my force by perpendicular distance plus my force times the perpendicular distance plus my force by my perpendicular distance. And that's equal to the anticlockwise moments, which is or times the perpendicular distance. So I can divide across there by L. And if I multiply my brackets, that gives me W plus 2W plus W over root 2 plus 2 mu or over root 2 is equal to 2 or plus 2 or over root 2. So that gives me 3W plus W over root 2 plus 2 mu or over root 2 is equal to 2 or plus 2 or over root 2. So I'm just going to multiply everything across by root 2 there. So that gives us 3 root 2 W plus 2 mu or is equal to 2 root 2 or plus 2 or. So we're going to have to take another part of the system to try and get mu on its own here. So we'll call that equation 1. Okay, so I'm now going to look at the system. And I had A, B, and B, C. So now what I'm going to do is I'm going to take the part of the system that's going to slip, which is the rod BC. And I'm going to take my fulcrum at B, because that will eliminate the contact forces between the rod AB and BC. So if I was taking the rod B and C, I would have my X and my Y. So by taking the fulcrum at B, I eliminate those contact forces. I have or, I have W, and the angle is 45 degrees, and that's L, and that's L. So by taking my fulcrum at B, that means that my clockwise moments will be W, and my anticlockwise moments will be or. And of course we have our friction as well, which will also be our clockwise moment. So if I take from the centre of gravity to B is going to be length L. We're looking for the perpendicular distance. So the perpendicular distance, well, if I draw my right angle triangle, here's my perpendicular distance, which happens to be the adjacent. And the adjacent is always h cos theta. So it's L cos 45. In other words, L over root 2 for my perpendicular distance. If I look at mu or then, mu or is acting along in this direction here. That's the angle 45. So again, perpendicular distance this time is going to be the opposite, and the opposite is always going to be h sine theta. And 2L sine 45 is 2L over root 2. And then if I look at my anticlockwise moments, again I have my rod BC, and or is acting up. So again, if I want my perpendicular distance to the fulcrum, well then, here's 45, so we have alternate angles, 45. So therefore this is the adjacent that we're looking for, where the hypotenuse is 2L. So the adjacent is going to be 2L cos 45, which is 2L over root 2. So now we have all our perpendicular distances. We can say our clockwise moments is our force by our perpendicular distance plus force by perpendicular distance is equal to my force by my perpendicular distance. So again, I can divide across by L, and I'm going to multiply across by root 2 again to get rid of my fractions. So if I multiply everything across by root 2 there, that gives me W plus 2 mu or is equal to 2 or. So again, I have 2 mu or is equal to 2 or minus W. Now if we look at the first equation, I actually happen to simplify it. So I had the mu on the left, and it's actually 2 mu or. So equation 1 is 2 mu or, equation 2 is 2 mu or, so I'm going to equate both of those equations. So by equating 1 and 2, we have 2 or minus W is equal to 2 root 2 or plus 2 or minus W minus 3 root 2 W. So now all I want to do is bring my ors to one side and the W's to the other side. So we have 2 or on the left and 2 or on the right, minus W on the left, minus W on the right, so that's going to be 0. So therefore that leaves me then with 2 root 2 or is equal to 3 root 2 W. And therefore if I get or on its own, well, root 2 goes into root 2 once, which then leaves me with 3W over 2. So now I know what or is. I can then work out my coefficient of friction. So I'm going to sub that into equation 2. By subbing or into 2, we end up with 2 mu or is equal to 2 or minus W. So that's going to be 3 mu w is equal to 3w minus w. So 3 mu w equals 2w, and therefore mu is equal to 2 over 3. So in terms of marks, well, we had 5 for setting up our clockwise equals our anticlockwise, and 5 for getting an equation out. And then we had 5 for setting up our second equation. And then we had 5 for getting or, and then 5 for getting mu. So 25 marks in total.